We'll do it Wednesday, Thursday. Okay, everybody, hyperbola. Shh. Wes slash.
That's two.
That's 2 for Wes. Okay.
One for Mark.
Duncan, I think you were in on that too.
Mark was in on that. You might want to mark him down.
Who was?
Just keep marking attention.
No,
he was. He had to stop talking since he came in here.
All right, everybody look at the hyperbola. A hyperbola looks like this. Okay, now we've talked about ellipses, and we know that ellipses are formed from 2 foci points, focus points, and this string between the focus points has to stay the same all the way around the ellipse. Okay, so the ellipse is a path of points that is generated from 2 focal points. The hyperbola, okay, look on this page here. We're on page 475. Ben, where's your book? Ian, 475. And you're looking at what is a hyperbola, okay? The hyperbola is another type of conic section whose locus definition and equation are similar to those of the ellipse. However, its graph is very different. The hyperbola is defined to be the locus of all points. Yes?
This just popped into my head.
Then don't say it. It scares me. Okay. The locus of all points.
Academic team today. No middle school academic team today. The following students have attention. Joseph Agan, William Everett,
Such that
Leanna Massey, Christopher Need,
all the points.
Nicholas Schneider, and Annabelle Schneider.
Okay. So that all the points.
Connie Lee.
Okay. So all points such that that absolute value of the difference of the distances from any point on the hyperbola to the 2 fixed points is constant. All right, so what they're showing you here in this picture is much better than I could draw. Okay, they're showing you the 2 focal points, okay, and they're showing you how the distance between each point on the hyperbola, the absolute value of that distance will always be the same. The difference between the 2 distances, absolute value, okay? Now, you don't really have to use that much, but that's the definition of the hyperbola. Now, the hyperbola is going to be x squared minus y squared is 1, where you have an a squared and a b squared. So look at the equation of the hyperbola and think of the equation of the ellipse and how much they are alike. There's only one difference. What's the difference? There's a negative in between them. That's the only difference, right? They're exactly the same except there's a negative in between them. Okay? Now when we graph hyperbolas, it's going to be a little different. Look on the next page. We're going to sketch the hyperbola x squared over 9 minus y squared over 4 equals 1. And when we do hyperbolas, we do a box. All right? So we're going to make a box. And this box is going to go 3 right and 3 left. 1, 2, 3, 1, 2, 3, up 2 and down 2. 1, 2, 1, 2. We'll finish hyperbolas. Okay, you guys, listen. Wednesday, we don't have class, so 75 is due Thursday. 75 is due Thursday.
I really don't have it. Yes, you do. I went to the bathroom the whole day. Yeah, and I found it.
Miss Aldridge, candy.
Candy at the door. Somebody go get it.
Guys, let's beat us that.